Singleton is a creational design pattern which ensures that only one object of its kind exists and provides a single point of access to it for any other code. In our real-life example, when you have any award ceremony, we want to make sure that each place on the podium will be occupied by only one person. In any unlikely events, there is a slight chance that two people will finish at the same time. This is where Singleton comes to play. It is providing interface that is ensuring that it will always return the same value. Like in real life, also in programming there are exceptions to it, so we need extra synchronization to make it work properly. But before we'll get to it, let's first implement the most basic version of Singleton class in Java. Complexity of this design pattern is very low as long as we are operating in a single thread environment. In this case, all we have to do is first to create a static private field of the instance of class itself. Second, to ensure that no one will have access to constructor to create more instances, we have to mark it as private. Next, we have to create a static method that will check if instance exists, create an instance when it's first invoked, and always return the same reference to previously created object. Now let's simulate multi-thread environment by invoking thread sleep to block this thread from further proceeding for 1 second during instance creation. For single thread is not a problem because all the operations are proceed synchronously and program will just hang for 1 second. However, if we run this code in a separated threads, they will operate independently. They won't have access to each instances during creation, so they both will create their own instances of this class. To run object creation in a separated thread, we have to create a class that implements runnable interface and override run method with class instance creation. Then we have to pass object of this class to thread constructor and invoke start method. Now to prevent such a behavior, we can implement so-called double-check locking. In this approach, we create a local variable result, which seems unnecessary. The effect of this is that in cases where instance is already initialized, like most of the time, the volatile field is only accessed once due to return result instead of return instance, which can improve the method's overall performance by as much as 40%. Synchronized keyword here is preventing from accessing this block of code by two different threads in the same time. By passing the class name in place of the object reference, the class is becoming a monitor for synchronization of this block. Prior to Java 5, the Java memory model had a lot of issues, so Bill Pugh came up with a different approach to create the Singleton class using an inner static helper class. Notice the private inner static class that contains the instance of the Singleton class. When the Singleton class is loaded, Singleton helper class is not loaded into memory, and only when someone calls the getInstance method, this class gets loaded and creates the Singleton class instance. This is the most widely used approach for the Singleton class as it doesn't require synchronization. The last approach is to create an enum class. Java ensures that any enum value is instantiated only once in a Java program, however it does not allow lazy initialization, since Java enum values are globally accessible, so the Singleton. Subscribe for more videos like this one.